Well, hello there. Like always, I want to try and get through a lot with you this time. So we're going to go ahead and get logged into my system. I've already started my learner lab. So there's a few things I want to do this time. I'm going to exit out. So I've downloaded a file called site.tar that I use with my students. That I'm going to use for this lesson today, but I'm not going to upload it to the internet. I don't think I have proper permission to do that. So what I need to do here is first I need to upload that file. So I'm going to change this from SSH to SCP, and it's in downloads site.tar, and I'm going to upload it to my system, and I'll just put it in my home directory. It's not too big, so happy day. So I'm going to just go back up and SSH right back in, and cool. So now if I do ls, I can see there's a site.tar there. Now I'm going to make a directory. TMP, we'll do temp. And I'm going to move site.tar into temp. And by the way, I could rename this while I'm at it. In fact, let's do that. Site.tgz. Because it's actually a TGZ file. I misname it intentionally because I want my students to understand that you don't have to name it how it should be, but it's actually a tar gzip file. So and that's good for us to name things correctly. So temp tmp, and I can see it's now called site tgz. Cool. So I'm going to tar, and I'm going to -x to extract. G, because it's gzip. Wait, no. T, Z is the compression. Verbose. And the file is site.tgz. And that will expand it. Okay? And now you can see why I can't share this. So we have a bunch of stuff here. Cool. Tree. Cool. So we have that. Now I also, you know what, that's good enough to get started. So I've unzipped things. Let's play with it a little bit, and then we'll zip it back up. Okay, so the first thing I want to do is I want to show you that if I look here, so there's a lot of different things here. So if I do find dot and look for everything in here, I can see a lot of different files. Now, I could do find. Let's just look at one of them, kind of. No. Let's do this. Let's grep HTTP from this file. And you see there's a lot of stuff in here. So there is some HTTPS stuff. That's good. But I also see there's a lot of HTTP in here. So there's not secure things. So that could be a problem. So how could I find out how many issues I have that they're not going to secure pages? So let's start with the find command, find dot, and let's pipe this. We're going to learn a new command. Because if I just pipe it to grep HTTP, I'm not going to find anything, because that's looking at find dot. It's going to be looking at for HTTP in these names. I mean, I could grep for insider, right? Grep inside. And I get those, but I'm not seeing inside the file. So let's come back here. And what we want to do is we want to do xargs. Okay? So this is going to take and run basically grep HTTP on the output instead of taking the output and grepping it. So it's kind of interesting. It just shifts things around the command line, but it's going to do a lot of cool things by doing that. And I don't need all the HTTPS. I'm only worried about HTTP, ones that are not secure. So I can do that and be able to understand how many there are. And that's a lot. In fact, watch this. Another thing we can do, pipe it to a word count, WC, that's a new one in this video series, -L, the number of lines. So I can see, there's 1,107 that I need to look at, lines. Now there might be multiple on the same line, because you saw it's kind of weird. If you look, we have some errors saying it's a directory. There's some things we could change in our command, or we can also send those to junk. We do that by using our redirect. So sending errors to /dev/null, which is basically saying go to nowhere. And now those errors are gone. Cool. Now, I'm going to play with this a little bit more in other videos, but I do want to show you that we could zip up just some things. So let's learn how to zip things. So if I do ls, and let's say I just want to zip up these two folders, okay? So, and I say zip, it's tar. So tar puts things together, and then we can compress them. And they're actually two different commands, but we can use different compression algorithms with tar, and it runs another command on it. It's almost like piping it, adding additional commands. So instead of tar, instead of extract, we're going to do C to create. I still want to compress it, and we're going to use Z for compression. Now, there's, like I said, there's different compressions. I want to be verbose because I want to see everything that I'm doing. I could leave the V off, and it wouldn't matter. It's just I wouldn't see things. And then F, and I need to tell it the file name. So I'm going to say new dot, and it's usually good to call it TGZ since we're using tar and gzip. Okay. So I've got it named. Now I have to tell it what to tar up. So I'm going to tell it to tar up this folder and this folder. And if I wanted to, I could even add some files, individual files, but I'm not going to. So I've got those two. Cool. We can see that it went through all of those. Awesome. Now, something else that we do often with things that we tar and compress is we try to protect them. Okay, so let me do that by first creating a simple file. So so let's echo, which I don't know if I've used it, but I haven't really talked about it. So that just kind of sends something to the screen. Echo, I'm going to say check this out. And we're going to send that to text file.txt. Okay? So I can cat text file.txt. Check this out. Cool. Now, if I want to keep something safe, I can encrypt it. Because encryption, you can it can go both. You can encrypt it and protect it, and then you can unencrypt it and see it again. So if I GPG, and this isn't going to work. That's okay. I know how to fix it. And I'm going to just do a single password encryption. Text file.txt. And see, I have an issue. That's because Amazon Linux doesn't quite have it installed properly. So I need to, in fact, I usually use this with DNF. So DNF, you could do it with Yum. So DNF and Yum are similar. They do the same type of thing. DNF is just a newer iteration of a package manager. DNF install, and I need, is it 2 dashes? Yeah, allow erasing. So what I'm going to do is I'm going to install something, but I need to erase it first. GNUPG2-full. I think that's what I need to do. Oh, and I need it as root. Yes. So if you notice, it's getting rid of the minimal, removing minimal, and we're getting the full. Okay, cool. Now, if I come back to that command, it's going to say, hey, you need a password. So let's give it a password. Okay, so I have a passphrase. And so if I look here, I now have text file and text file.gpg. So if I cat text file.text, check this out, cat text file.text.gpg, I don't know about you, but I can't read that. That's encrypted. Okay. So what happens if we accidentally remove text file? rm text file.text. It's gone. So all we have is this garbled one. So what I can do is I can decrypt it by using GPG. I think I don't need anything else because I think it knows. Text file.gpg. Now, if I was doing this on a new system, it would ask for my password. But this system has in my session my password. So it's encrypted with one passphrase. It knows my passphrase. So it tried to decrypt it. And there it is. And if we look at it, it's back. Sweet. Now, since we're talking about encryption, let's just talk about hashing while we're at it. So, in fact, I used to always use the MD5 sum. It's not got good anymore. And you can take an MD5 sum of a file and it gives you some general information on it. It's hashed. But there's some issues with MD5 sum. So we have SHA-256 sum of a text file, and that's better. And in fact, there's SHA, I want to say 512 sum of a text file. And this is just a mathematical representation of what's in the file. Now, what happens if I change, in fact, let's copy text file.text to A. And let's run these same things. Well, let's just run this one. SHA-256 on A. Okay? And we should see it's exactly the same because it's exactly the same file. It just has a different name. So it's looking to see what's in the file. Now let's change just one thing in A. VI A. And let's change the capital C to a lowercase c. Okay? Not a big change, right? Now let's run the SHA sum on it. And look, it's totally different. It's a mathematical equation that changes drastically even with minor changes. So you can understand if something has changed. Now the problem is I can't go back. If I was to save this as a file and delete the file and try to go back like I did with encryption, you don't do that with a hash. Hash is a one-way thing. There's not a way to mathematically get it back. Now, hackers, what we do is we can just start hashing everything until eventually we find that hash. And I would find that hash when I hashed, check this out. And the hash would be the same, and I would know that I've got it. I mean, there's possibilities for collision, but when it comes to a hash, that's kind of how passwords work, and it would just get me in. So usually things that we store as hashes are passwords, because we never need to know what they are. Things that we store as that encrypted are things that we need to remember what they were, so we have to be able to decrypt them. But I need to know my passwords, but the sites that I use, they don't need to know my password, they just need to know that it matched. So they don't need to store my password, they just need to store the hash. And then usually what we do is we salt the hash. And so what that does is we just put something additional that's random here, and we store that with the hash, so that we put that random thing on the end or beginning of this and run the hash algorithm so that there's some randomness. That way someone can't just run the hash on a specific group of words and use it everywhere in the world. You have to use the salt as well. Anyway, that was a lot. I hope you've enjoyed this, and we'll see you in the next video.